last section we looked at equivalent fractions, but we wanted to build the equivalent fraction. So we started with a smaller numerator and denominator and looked at creating an equivalent fraction with a larger numerator and denominator. And this was called building. In this particular case, remember that what we did, we multiplied both numerators and denominator by the same amount, using that fundamental idea in fractions, right? So 3 times 3 gave us 9, and 4 times 3 gave us 12. This time, what we want to do is we want to move in the opposite direction, and that opposite direction of, say, 9/12, what is it equivalent to? It's called reducing the fraction. The process of reduction of the fraction can happen in different ways. We'll talk about using the HCF or GCF. And HCF means the highest common factor, and some people use the word GCF, so that would be the greatest common factor. And then the second way will be by inspection, and we will look at some examples as we go through. Now, before we can start looking at the HCF or GCF method, the first thing that we need to look at or recall is this idea of divisibility. So let's go back to something that we learned with nice whole numbers, right? And we talk about a number is divisible by another if there is no remainder after division. So the divisibility rules for some of the first 4 prime numbers, 2, 3, 5, and 11, are given here. And so if I said, is something divisible by 2, could I divide by 2 and not get a remainder? All I have to do is look at that last digit. Is it divisible by 2? So if I gave you something like 54 without even doing much, because the last digit is a 4, I would know, yes, this is divisible by 2, and then I would proceed. All right. If I look at division by 5, I'm skipping the division by 3 or divisibility rule for 3 right now, because it's one that you always seem to forget. So let's look at the 2 most popular ones that most students remember, and that is division by 2 and division by 5, or divisibility by 2 and 5. If a number ends with 5 or 0, so if we had 75, the fact that it ends with a 5, we know that this will be divisible by 5. If we have 20, it ends in 0, it will be divisible by 5. Right? Now, the ones that we seem to forget are divisibility by 3. So if the sum of the digits, notice this is a little different now. We're talking about the sum of the digit, is a multiple of 3. Then this number is divisible by 3. So if we look at an example, if we even go back to this idea of 54, the fact that if I add 5 plus 4, these are the digits that make up 54. It's 9. 9 is a multiple of 3, so therefore 54 is divisible by 3. If we looked at larger numbers, 2,520, right? Already I can see definitely it is divisible by 2 because it's even. It's divisible by 5 because it ends with 0. But is it divisible also by 3? And so let's look at the digits. We have 2 and 5, that's 7. 7 and 2 is 9. And again, we get something that is divisible by 9. Now these two examples are summing to 9, but it doesn't have to end up being 9. It could be some other number. So if I, just to be different, let's even look at 156. If I sum these, we have 1 plus 5 plus 6. This is 12. Hence, 156 is divisible by 3 without, and hence it doesn't leave a remainder. All right, now the weird one for some of you, or you've never really done, is division by, or divisibility by 11. And I'll just put in these two because it's something that you probably haven't dwelled on much or so, or if you did it, you've done it previously and it's not in memory. All right, when we're doing checking if something is divisible by 11, what we do is we look at alternating digits. So if I look at 3,465, it's when the first, third, fifth, etc. So I'm looking at all the odd digits placed from the highest place value. So if I add these, 3 plus 6, we get a total of 9. I'm also going to add the second, fourth digits, and we end up, if we add those, 5 and 4, 9. If these sums are equal or do they differ by a multiple of 11, then it will be divisible by 11. We can bring up, or we can even check quickly in case you don't believe this. 11 into 34 goes 3 times. 3 times 11, 33. I would get 1 remainder, bring over, you get 16. And then I'm doing short division, so I'm saying that this is 11 times 315. So when we divide 3,465 by 11, this is the divisibility rule shows that 11 is what we call a factor. Just taking that to a little bit higher level, and I've sort of preempted and started this a bit. If we go back here and look at the digits that I have, we will sort of put them together and see what sums we get. 2 plus 4 is 6. 6 and 0 is still 6. And 4, 10. So we get a total of 10 for the first, third, fifth, and so on. Now let's do the second, fourth, etc. It doesn't matter if you're counting from the highest place value or lowest. It's just alternating digits that you're looking at. 9 and 7 is 16. 16 and 8 is 24. 24 and 8 is 32. Remember what this said? Says that if they differ by a multiple of 11, so let's look at the difference between these. 32 minus 10 is 22, and this 22 is a multiple of 11, so if I should divide this number, 294,708,480 by 11, I will not end up with a remainder. It will be divisible. Let's just quickly see if you can identify of these 5 numbers here, which ones will be divisible by 2, 3, 5, or 11. All right. So starting off with 138. It is an even number, so definitely it is divisible by 2. If I check 3, 1 plus 3 plus 8, taking the digits and summing them, I get 12. So 138 will also be divisible by 3. It is not divisible by 5 because it doesn't end with 5 or 0. And if I now check 1, let's look at the alternating digits. 1 and 8 would be 9. And then here is the middle one, minus 3. The difference is 6, which is not a multiple of 11, so no. Right. 184 ends with an even number, so definitely divisible by 2. If I add 1 plus 8 plus 4, this is equal to 13, so it is not divisible by 3. Likewise, doesn't end in 5, so it's not divisible by 5. Doesn't end with 5 or 0, rather. And if I look at the alternating digits, 1 and 4, 1 plus 4 is 5, and 8 minus 5 is 3, doesn't work. Right. Number 2, for 267, it's an odd number, so I don't even have to check that. Let's add the digits here. 2 plus 6 is 8, 8 and 7 is 15, so this will be a multiple of 3, or divisible by 3. And, sorry, I said 267 is not is a multiple of 3. Let's see, 267 is not divisible by 5 and not divisible by 11. If we continue, this is an odd number. 4 plus 0 plus 5, when we sum the digit, is 9. So 405 will be divisible by 3. It will also be divisible by 5 because it ends with a 5 and does not work for 11. This is odd, and I think you're getting the hang of it. If I sum these digits, 12 and 5 is 17. That's not a multiple of 3. Ends with a 5, so it's definitely divisible by 5. 9 plus 5 is 14. And if I subtract 3 from that, I get 11. So yes, this will be 935 is divisible by 11. Right, so that was a good recap of your divisibility rule. So what we're going to do now is use those divisibility rules in order to turn around or reduce our fractions. So the idea behind this reduction is if we take our original fraction and we find a common factor, we can divide both numerator and denominator by that common factor. So let's look at a few fractions or a few examples. If I have 30 divided by 45, what do I get? I could do a couple of things. Number one, we could say, both of these are divisible by 5. So let's try that. Because they end with a 0 and 5. We ended up with 6, and 45 divided by 5 is 9. Am I done? This is the important part now. Most students stop, but you have to look again. I look, I see 6 and 3, so I have to continue because this is not reduced completely. It is lower, but it is not completely reduced. Right, and so we go again, 6 and 9, the common factor is 3, and we're going to divide again. And we end up with 2/3. That will be my final answer. Many of you might have learned this method also. We could do what we call a tree method and find the prime factorization of both 45 and 30. So just give me a moment and I would write them out. Here is 30. I can write the tree value 2 times 3 times 5, and likewise 45 was 3 times 3 times 5. So if we go back, we could, here's an alternate way that some of your teachers might even ask you to do. That is, take each part, a numerator and denominator, and write them as prime factors. Now what you will notice is that what you were dividing out were these two. Essentially, I can go back in and say 3 into itself is 1, 3 into itself is 1. I am dividing out 3 from both the numerator and denominator. I would encourage you to get very colorful when you're doing this and use different colors, and make sure, so as I say, 5 into itself is 1, and do ensure that you place the 1 in both numerator and the denominator, so that what you're ending up with is this. 2 times 1 times 1 over 3 times 1 times 1, which is simply 2/3. So again, we come back to the equivalent fractions. 30 over 45 is the same as 2/3. Let's do one more. And we have, let's say, if I have 32 over 56, here's a shortened version that you can, well, let's do it the longer way first. We see that both of them are even, so the smallest number I could divide by is 2, and we'd end up with 16. 56 divided by 2 would be 28, and it's still even. These are both even numbers, right? So we need to continue, and we continue. 16 divided by 2 and 28 divided by 2. So we have 8 and 14, but again, still even. Keep going. 8 divided by 2, 14 divided by 2. And we have 4 and 7. So we see consistently dividing by a prime number, we will eventually get to the answer. We can do this a little faster if you know your times table. So probably I think most of you might, if you didn't even see the 8 as a common factor, at least you could have seen the division by 4. 4 into 32, or 32 divided by 4 is 8. 4 into 56 would be 14. And then you would continue from here, where we then divide by 2. Okay. So 4 over 7. As you get better, here is something that you will see or will even do. 18, let's take 18 over 30. All right. I'd encourage, this method is we're reducing, but the slashes will indicate that we're dividing both numerator and denominator by the same number. So if I started out, I'm going to divide both numerator and denominator by 2, and that of course will leave 9 and 15. And I like the color here. In fact, I remember when I was very young, we were encouraged to have color in our pencil cases so that we could match these. So the red ones went together. And here now I'm going to use my blue slashes. I'm dividing by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. So my final answer from this is 18 over 30, or 18 divided by 30 is the same as 3/5. And that's